Today we're going to talk about quadratics in vertex form. And so our last unit was all about solving quadratics. We tried to figure out where did the graph cross the x-axis. And first of all, that formula, ax squared plus bx plus c, is the formula of a quadratic equation. It has the highest degree of 2. The y-intercept of this function is 0, c. So there we have it written as an ordered pair. The equation of the axis of symmetry being a line that goes right through the middle of the quadratic, cutting it in half, so that the right side, when we fold it across that line, will land directly on the left side, or vice versa. The axis of symmetry has a formula. It's x equals the opposite. I'm trying to write that negative directly out in front of this fraction, which is negative b divided by 2a. The opposite of b over 2a. And then the x-coordinate of the vertex is that value. So what we just find, when we find this is an equation, so I want to underline that. That's going to be an equation. You need the x equals. But oftentimes when I write this as negative b over 2a and a comma. Because the next part of the sentence says, use this value to find the y-coordinate by plugging that number back into our equation and solving for y. And again, the calculator can be of some help to us on this. As we look at an example here, it says use the formula of x equals the opposite of b over 2a to find the turning point for each of the following quadratic equations. So what we're going to do, first of all, is we're going to start this by saying that a is 1. It's the number in front of the x squared term. B is 10, the number in front of the x. And c is negative 27. So it kind of looks like we're going to be using the quadratic formula. We're not, but we want to identify those values so that we can put them back into this formula of x equals the opposite, and the formula is listed up there, of b. Well, our b value in this is 10 divided by 2 times a. That's what's going to go in the bottom of our formula. And then what we're looking for here is what's that value. And if you need to, you can type that in your calculator. But what we end up when we type this in our calculator is x equals 5. And how about negative 5? 10 divided by 2 is 5, and there's a negative. Again, you can type that in your calculator. And why don't I just do that? It's alpha y equals, for the fraction button. I actually need to have a negative out in front of that. And then it's 10 divided by 2 times 1. So there is with the fraction button. Without the fraction button, we're going to type in negative, and then it's going to be 10 divided by parentheses 2 times 1. And we still get negative 5. So there are our two values there. And that's our equation of the axis of symmetry. It's going to be the line that cuts right through the middle of the graph. And I'm picky about that. You need to have the x equals because it's an equation. Now, once we find that value, then our vertex is going to be negative 5 something. And the way that we figure out what that something is we're going to take that value of negative 5 and we're going to put it back into this equation wherever we see x. So typically I don't write it, but I want you to see it on your notes, and certainly if you're watching the video, you need this. But we're going to take that negative 5 and we're going to put it back in for the x, because it's x squared plus 10 times negative 5. Again, putting it back into the given equation for the x, minus 27. So we can come over here and we can type that into our calculator. And when we do, parentheses, negative 5 squared plus 10 times negative 5 minus 27. And when we type that in, we should get the other value here, which is going to be negative 52. And lastly, I probably should have done it first, but to find the y-intercept, it's probably the easiest because our formula is 0c. And the c value, we listed it right at the beginning, is negative 27. So it's 0, negative 27. Now that we've seen one, let's try another. Again, let's start off with what does A equal, what does B equal, what does C equal? A equals 2, B equals negative 12, C equals 7. Certainly helpful to have a calculator, especially because this one's going to have a fraction in it. But let's start off with the y-intercept because it is the easiest one conceivably if you know the formula. And that is, it's 0c. And we just listed what A equals, what B equals, what C equals. So this is going to be 0, 7. That's where the graph crosses the y-axis. So we want to find the equation of the axis of symmetry. And you can't see it on this particular problem, but again, it's the opposite of B divided by 2a. So we're going to fill in those values. And when we fill these in, we get x equals negative, and then b is negative 12, divided by 2 times 2, and we don't get a fraction, at least not here. I was thinking we did. Worst comes to worst. Type it in your calculator. But it's negative, and then it's negative 12 divided by 2 times 2. Notice all the parentheses that I have in there. But we get 3. With the fraction button, alpha y equals. Again, I need to have that negative out in front. But it's negative 12 divided by 2 times 2. Still gives us 3. So when we write this, this is going to be x equals 3. The x equals is really important. And once we find the axis of symmetry, again, which is the line that splits the graph in half, it goes right down the middle, the vertex is going to be 3 something. And what we need to do to figure out what that vertex is we're going to take 3, the value that we just found, and put it back into our equation wherever we see x. So it's going to be y equals 2 times 3 squared minus 12 times 3 plus 7. And again, that's a place where you really want to use a calculator. At least I think you do. So we go back into our calculator and we type it in. So it's going to be 2 times 3 squared minus 12 times 3 plus 7 gives us that value of negative 11. So our vertex is 3, negative 11. So sometimes we have another format for our quadratic. Instead of the ax squared plus bx plus c, we have what's called vertex form. But a quadratic function is in standard form when it's written, just like I said, in the f of x equals the ax squared plus bx plus c. And that's where the leading coefficient a is not 0. And that's essentially what we say up there at the very beginning of our notes here. But there's another format, which is there on problem 2. A quadratic function can also be written as the function f of x equals a times x minus h quantity squared plus k. And this form is called the vertex form of a quadratic function. And it allows us to identify certain parts of the quadratic. For instance, the turning point, which by the way I sometimes abbreviate as TP, the turning point, also known as the vertex, is HK. So we can identify that right away. The axis of symmetry is a line that divides the graph in half, creating the mirror image. So there is what we've been talking about. The formula for it, when we're written in vertex form, is that it's going to be x equals the h value. And again, still picky about the x equals. It's an equation, so we need to have the x equals. One more interesting piece of use for us when we're talking about these types of problems is that the value of a. If the value of a is greater than 0, the graph opens upward, and the turning point is going to be a minimum. Ooh, got to spell it right. Minimum value. If a is less than 0, then our graph is going to open downward. And our turning point, also known as the vertex, is going to be a maximum value. So it gets us back into some old language here. By the way, your picture would look like this for number 2. And if we have a quadratic that opens upward, what it's saying is this point, our turning point, is going to be the lowest point in the graph. And then when it opens the other direction, our turning point, also known as our vertex, is going to be the highest point in the graph. So flipping our paper over, complete the following information about each function. You may use your calculator to help you graph. So maybe what we want to do, and actually I'm not going to do it on this one, I maybe will do it on the next one. Oh no, because it says complete the following information about each function. The thing is, problem number 1, it's in vertex form. So we don't really need to type it into our calculator, but maybe the calculator will help us. If we see the picture, it will help us identify these different pieces. So let's start by typing in our function, which is parentheses x plus 3 quantity squared minus 4. And we can look at our picture, which looks like that. But realistically, what we want is we want to see the table here so we can get at least 3 key points. In fact, in general, I tend to graph 5 to 7 of them, depending on how it fits on the graph. But if we want to get to the table, we're going to go to second and graph. And I'm going to get a couple of negative values here. And that'll be helpful for a moment here. As we look at the table, here we can graph. Negative 6, 5. Negative 5, 0. Negative 4, negative 3. Negative 3, negative 4. Negative 2, negative 3. Negative 1, 0, 0, 5. And again, the directions say plot 3 key points. I'm going to graph more. we've got a calculator that helps us, and sometimes it's easier than others. But there is roughly our picture. But the thing by drawing a really complete picture is we can identify the turning point, which is also known as the vertex, and it is -3, -4. By the way, our H value is coming from here, our K value is coming from there, but what happens within the parentheses, since the formula is X minus H, we change the sign. Since it says X plus 3, we make that a -3. And that's something that you could forget on an assessment, but if you look at the picture, you don't even have to worry about it. Well, the next part that we see on this is that green point a maximum or a minimum value? And we can see that it's the lowest value on here. So we're going to say it's a minimum value. Do we have a high point? Do we have a low point? That's going to be important here in a minute when we talk about domain and range. The axis of symmetry is the line that goes right down the middle of the graph. So I drew it in red. That's the axis of symmetry. If we fold that graph in half, the right half of the graph will land on the left half of the graph. The equation is x equals, and it's our h value, which is -3. Other way to look at it, where does it cross the x-axis? It crosses the x-axis at -3. Y-intercept? Well, our y-intercept is going to be 0 something. I can't see it very well on my, oh yes I can. Can't see it very well on my picture, but that's what's helpful about looking at the picture on the screen as well, is our y-intercept is here. If I scoot it over, and I don't know if I can, here. And I can't get rid of that now. Delete. But 1, 2, 3, 4, 5. It actually is right here, so it's going to be 0, 5. By the way, sometimes you can see that on your screen, and sometimes you can't. If you can't, you can go back once again to the table and look, 0, 5. When we're looking at that, here's the 0, 5. That is the y-intercept, where the graph crosses the x-axis, sorry, y-axis. Roots. What does x equal? In other words, where does the graph cross the x-axis? It's going to cross at those pinkish purple points. So in this case, what we see is it crosses at the value of -1, as well as, is it 1, -5? Don't put parentheses around there, it's not a point. Those are the two places that it crosses. And then lastly, our domain. Well, our domain is all real numbers. -infinity to infinity. But our range is not. Again, it goes back to, do we have a high point? Do we have a low point on the graph? And we have a low point. We have a minimum over here. And when we have a minimum, we're going to start at that y value, which is -4. It is a point on the graph, so we're going to use a bracket. And we're going to continue to go up and up and up and up. So this is going to be -4 to infinity. Infinity always has a parenthesis. Problem number 2. Similar to problem number 1. And again, let's start by sketching, because the sketch could really conceivably help us figure out most of these answers to these questions. So we'll go to our calculator. We're going to go back to y equals, and we'll get rid of that equation, and we'll type in our new equation, which is x minus 7 squared minus 1 and we'll draw our picture. So here we get what our picture looks like. And now that we know that, it gives us at least a little bit of an idea of what it looks like, and then we can go to the table, second and table, and find some values there, and I need to scroll through a little bit to find some that'll fit on the graph. And I think that'll work here. And again, it says plot 3 key points, and I'm going to plot more than that, but on this one, 4, 8 fits, and 5, 3, 6, 0, 7, -1, 8, 0, 9, 3, and 10, 8. And you don't have to have as many. I just find it helpful to have a really good picture. It's a personal preference. In terms of probably the most important points, I think that the most important points could be this point and these 2 points right there. And the first point that I marked, which I'm going to switch over to blue now, was that point right there, which is our turning point. And our turning point then is 7, -1. And this is our H, and this is our K. And once again, what happens is it says X -7. So notice that my X value is +7. I changed the sign to get the +7. The -1 remained the same, but the picture can be helpful for that. In this particular problem, once again, what we see is that that blue point on our graph is a minimum. It's the low point of the graph, and that's going to help us find our range in a couple minutes. The axis of symmetry, it goes right down the middle of the graph. You do not need to draw it in, but this might be a new topic for you, so I want you to see. So there is our picture here, and what we get for the axis of symmetry, it's going to be x equals 7. And really, I should label the h and the k here, but the h comes from that -7. The y-intercept, we cannot see it on this picture. Where's across the y-axis? That's when we want to go back to our calculator, and we want to look at the screen, and I need to scroll a little bit because I can't see the 0. But once I can see x equals 0, we can find our y-intercept. We just had to use it on the table here. I'll scan that in. But I'm going to write, let's see, what color do I want to use? Circle this. That's our y-intercept. So when we put that in here, 0, 48. The roots. Where does the graph cross the x-axis? Well, we have them marked already with black points. And those roots are 6 and 8. Our domain. Our domain is still all the numbers. Negative infinity to infinity. But our range is not. And again, when we're looking at the range, we ask ourselves, do we have a high point? Do we have a low point in the graph? And we have a low point. The lowest point is that blue point. And the y value of that blue point is -1. So when we write down our range, it's going to be -1. It is a point on the graph, so we're going to have a bracket. And we continue to go up and up and up and up, which is going to give us our parentheses. So if we take a quick look at the last one here, I'll try to go a little bit quicker. But starting here with our picture, when we type it in, it's going to be negative, and then x minus 2 quantity squared plus 9. Here's a picture. It looks a little bit different. And then the table. Second table gives us some values here. And I'm just going to scroll a little bit more here to get a couple of values to help us graph. And this one, -2, -7, -1, 0, 0, 5, 1, 8, 2, 9, 3, 8, 4, 5, 5, 0, and 6, -7. So I've got a lot of points on here. That is a personal preference. And again, I find it particularly helpful when it comes to identifying all the information over here, because we can see our turning point. Turning point, also known as the vertex. Our turning point is 2, 9. And the 2 is the H. The 9 is the K. The 2 came from the value that's in the parentheses. It said x minus 2. We changed that sign. This time we have something different. That blue point is the highest point on our graph. So it's the maximum. The axis of symmetry goes right down the middle of our graph. It splits it in half. So if we fold it along that line, the right half of the graph lands on top of the left hand of the graph. And it's an equation. Again, I want to stress, it's x equals, and then where do we cross the x-axis? Well, we cross it at 2. The formula is actually x equals h. If you look back on the front of your paper, the y-intercept, we can see it on this particular graph. It is here, the green point, and our intercept, our y-intercept is 0, 5. Where the graph crosses the x-axis are our zeros, are our roots. Those are going to be at the pinkish purple points, and it looks like they are at -1 as well as 5. Again, don't put parentheses around there. It's not an order pair. Our domain of our function is the same as the previous two. It's all real numbers, -infinity to +infinity. And then our range. Do we have a high point? Do we have a low point? We have a high point. So where we're going to start, we always have to go in order. It's always going lowest to highest. So we're going to start at -infinity. Again, infinities, whether they're positive or negative, always have a parentheses. And then we're going to keep going up and up and up and up. The highest value is going to be at our blue point here. It's the y value of that blue point, which is 9. And 9 is on our graph. So we need to have a bracket on that.